Okay, problem 1. The function is given. And you want to know its local maximum and local minimum. So for the local maximum, the graph is like this. Right. So first way to define point A a local maximum is that, right, your f prime A is 0 and your f double prime A is smaller than 0. Okay, this is the first method you can define A to be your local maximum. The second method is at this point A, the derivative is 0, right? When it is greater than A, this part, the derivative, you can see the graph, the function is decreasing, right? At this point, the function is decreasing. So the derivative, when x is greater than A, it's smaller than 0. When x is greater than A. Okay, and this part, right, so this part, the derivative, let me write down. The derivative, you can see at this part the function is increasing, so the derivative is positive when x is smaller than A. So there are two ways to define this point is a local maximum. So let's use the first way. So what about the local minimum? So for the local minimum, okay, let me write down here. For the local minimum, the graph is like this. Okay. So again, the first way is, okay, by the way, this is called the second order derivative test. Second derivative test. This is called the second derivative test. And this method 2 is called your first derivative test. Both of them tells you whether this point is a local maximum. Okay. Then for local minimum, it's just the opposite. The local minimum, the first order derivative is also 0. The second order derivative, as you can see, the function is decreasing first, then increasing. So the second order derivative is greater than 0. Okay. Again, this is called the second derivative test. Right? This is called the second derivative test. And the other way is, right, so at this point A, the derivative should be 0, right? When it's slightly greater than A, so you can see when it's slightly greater than A, the function is increasing. So when x is slightly greater than A, the derivative, it should be positive. Okay, when the function is slightly smaller than A, the derivative, you can see when function is slightly smaller than A, the function is decreasing. Right, so the derivative, it should be negative. Okay, so this is the first derivative test. Okay, this is a local minimum case. This is a local maximum case. Okay, so let's try problem 1a. So fx, it's x to the power 5 minus 5x plus 3. So f prime x is 5x to the power 4 minus 5. Right. So f double prime, it's 20x cubed. So first, you should find the point, right? You should find the point, which means you should find all the point that the derivative equals 0, which means 5x4 minus 5 equals 0, x4 equals 1, x equals 1, or negative 1. Right. So for point 1, for x equals 1, right, your second order derivative, it's 20 times 1 cubed, which is 20, which is greater than 0, right? Which means And you know that your first order derivative is 1. First order derivative is 0. So combine these two facts, your f1 is a local, because this is positive, right, is a local minimum. Okay, so this is a method of second derivative method. Okay. So the question asks you to use both first and second. So here I use the second derivative test for question A. I will use the first derivative test for question B. Okay. So for question A, I will just use the second derivative method. So for x equals -1, the second order derivative is 20 times -1 to the power of 3, which is -20 smaller than 0. Right. And you also know that the first order derivative is 0. Combine these two facts, you know that f-1 is a local. It's smaller than 0, so it's local maximum. Okay. So for question 2, so let's check, is there any mistake? Okay, I don't think so. Then let's go to question 2. Okay, I should use first derivative test for question 1 as well, but I think it's too much, it's too complicated, so I'll just use it in part B. Okay, part B, your fx is x over x squared plus 4. So now I'm gonna use the first derivative test. So for first derivative test, still I have to figure out when the derivative is 0, right? So what's this derivative? It's a quotient rule. Right, it's going to be 4 minus x squared over. So now, this thing, right, it's not going to be 0, right? Because this thing is greater or equal to 4, and this thing is always positive. So when fx derivative, f prime x equals 0, which just means the numerator equals 0. Right? Because your denominator is always greater than 0. So your x is positive or negative 2. Okay. When x is positive 2, so let's check its derivative. So f prime x, right, when x is negative x. Okay, and we can draw this table. Okay, let's draw this table. For x, right, it's at positive 2, it's slightly greater than 2, right? This means you are slightly greater than 2, you're slightly smaller than 2. Then what is the derivative? So at point 2, the derivative is 0, right? When it's slightly greater than 2, you can see if this thing slightly greater than 2, right? You can see if this thing is like 2.1, this thing is negative, right? So when x is slightly greater than 2, the derivative is negative. When x is slightly smaller than 2, you can see, for example, this thing is 1.9, right? This square is 3 point something, so it's going to be, the numerator is going to be positive, right? So the derivative is going to be positive. All right. So the function is increasing, so we can say slope. The function is increasing when x is slightly smaller than 2. It doesn't change at point 2, and it's going to decrease after x is greater than 2, which means, right, what is your f2? Your f2 is a local maximum, right? Your x is a local maximum. So similarly, at point -2, right, your x is slightly smaller than -2, slightly greater than -2, right? Then your derivative So let's copy the formula of derivative. It's 4 minus x squared. Okay, x squared plus 4 to the power square root. Okay, it is 0 when x is at negative 2. And when x is slightly greater than negative 2, for example, x is negative 1.9, right? You sub in negative 1.9. You can see this thing is 3 point something, so it is positive, right? It is positive. When x is slightly smaller than negative 2, for example, x is negative 2.1, right? X is negative 2.1, you sub in, it's going to be 4 point something, right? So it's 4.21. So this derivative is going to be negative. The numerator is going to be negative, the derivative is going to be negative. So for the slope, right, it doesn't change at point negative 2, and it's going to increase after negative 2. It is decreasing before negative 2, which means so f negative 2 is a local minimum. Okay. So let's check, is there any mistake? Okay, I don't think there's any mistake.